And the next presentation continues the subject of the electronic properties of functionalized carbon nanotube. And the presenter is Whitney. So she will look more on the electronic structure side of the carbon nanotubes functionalized by oxygen.
Hi, I'm Whitney. So today I'll be talking about the oxygen absorption on single-wall carbon nanotubes. So first off, I will go through the introduction and I'll talk about the motivation of this project, and then I'll talk about the methods, result, and then finally the conclusion. So first off, the introduction. A carbon nanotube is a folded sheet of graphene, or a sheet of carbon.
I just have a suggestion. Since he already introduced it, right?
Oh,
you probably
yes,
can
sure.
skip it and save time for results, right?
Okay. And then some of the applications, including electrochemical gas sensors, and they also use in polymers to control and enhance conductivity. They're added to anti-static packaging. So why am I talking? So for gas sensors, it can induce a strong change in conductance, and then the carbon nanotube can be used to detect gases such as NO2 and NH3 or oxygen, and experimental data has shown that oxygen increases conductivity. So we are using computational methods to look at this thing. So I use, to build and edit the models, I use Avogadro, JMOL, and VASView. And when I run the jobs, I use the VAS software. And then I use a 3-unit cell of carbon nanotube folded at 4,0, and I manipulate the position of oxygen on the carbon nanotube. So after optimization, I found out that the bandgap of the modified system definitely decreases compared to the pristine. This one, I have one of the carbon substituted with oxygen, and a few other cases where I have just I remove one carbon from the nanotube and just have one oxygen molecule on top of it, and the other one I just put either parallel or perpendicular to it just to look at the result. And the bandgap definitely decreases significantly. And then when we look at the absorption spectra and the molecular orbitals, for the pristine structure, we have the absorption spectra at 0 frequency, but for other systems, they decreases significantly for the absorption spectra. Yeah. So in conclusion, the oxygen definitely decreases the bandgap and thus increases the conductivity. The change in absorption spectra also proves that the oxygen is present.
Okay, let's thank Whitney for interesting presentation and for being record short.